function and velocity and how it relates to calculus. So initially we have this thing called a position function, which is in this example. So position function is a function that calculates where an object lies at a certain amount of time, at a certain time, I should say. So now our variable shifts from being an x to a t, and it's commonly denoted with an s. So s represents a position function. We can go through the derivation of it, and you've done this already in physics, where you calculated things based on gravitational constants, those kind of fun things. From a calculus standpoint, we look at a simple calculation, and that is distance over time, also known as the Dirk equation. You've heard that before, right?
Yeah.
Okay. Rate is distance divided by time, so therefore distance is rate times time, hence the Dirk equation. From a calculus standpoint, we're going to look at the average velocity there being delta s over delta t. So how does that relate to calculus? We're going to be comparing the slope of the secant line to the slope of the tangent line. So we introduce a bunch of math here to explain the physics involved in this scenario. And it has to do with average velocity versus instantaneous velocity. Do you understand the difference between the two?
Yes.
That's one of you. No? Good. That's all I need to hear. So I'll review. Let's suppose you start at your house and you drive to Target. And it takes you an hour to get there because you're a horrible driver. And it's 10 miles. Okay, you live very far away from your target. You can calculate your average velocity, right? Total distance divided by total time. Okay. Now, does that mean that you're doing 10 miles an hour at every point along that trip? No, you didn't back out of your driveway doing 10 miles an hour, and you weren't going down the street at 10 miles an hour. I just did the calculation. You're driving 10 miles an hour at a Target. Bad example, but you understand what I mean. Okay. Average velocity is the average time that you travel over the same distance. Okay, so you go to visit a college, your average velocity might be something like 45 miles per hour. At any point in time along that trip, though, you're going to have a different speed. So if you stop at an Oasis to get a cheeseburger, your instantaneous velocity is going to be 0. You're not going anywhere. But going down the highway at that moment, 12:04, your instantaneous velocity is going to be, say, 65 miles an hour. Okay. From a math standpoint, we relate that to the slope of the secant line versus the slope of the tangent line. So it's algebraic slope, which is the slope of that secant line that we did the f of x plus delta x minus f, all that business, versus the calculus, which is then taking the limit of that. So in simplistic terms, the average velocity is the total distance divided by the total time. So we start with an example here with average velocity. So I've got a billiard ball that's dropped from a height of 100 feet. You probably did these ad nauseum in physics, yes?
Well,
yes?
yeah, at some point.
At some point you did these calculations. So the negative 16 t squared should look familiar. Does it not?
Is that like a constant?
It's the acceleration due to gravity constant. And it tells you all that other business, that s is measured in feet, t is measured in seconds, the average velocity over the following time intervals. Okay, so we take a physics problem and relate it back to a math problem. And as I said, average velocity has to do with the slope of the secant line. So we're going to generate a secant, and in order to generate a secant, we need 2 points. Well, where do I get those 2 points? I'm given 2x points in part A. I'm giving a starting value of 1 and an ending value of 2. But what I need is the y values. So you're going to need to do some calculations, by the way. So if you get out your calculators, I'd appreciate it. This is not a point. It's in brackets. It's actually an interval. So we're wondering, what's the average velocity from 1 second to 2 seconds? So what I need to know is, where is it at 1 second? So I do some calculations, plug in 1 for t, and I get 84. Then at 2 seconds, I plug that in, and it's located at 36. Does that make sense?
Yeah.
Why?
Because that's distance from down, and it's going down.
Drop from 100 feet. After a second, it's 84 feet. After 2 seconds, it's at 36 feet. We could calculate how long it takes to hit the ground. We don't care right now. We just want to know average velocity. Okay. It's not really a calculus topic. It's basic algebra. Now calculate the slope between those 2 points. 84 divided by 36. Sorry, 84 minus 36 divided by -1. So 84 minus 36 divided by 1 minus 2. This will be velocity average. What is that, -48? Yeah. Why is there a negative sign there? Lexi? It's going down, right. So velocity has direction, and direction in this case would be negative. What are my units? Feet per second. The other calculations all do the same thing. And there's a reason why I have 3 calculations on there, because I'm working, if you'll notice, I'm starting and going from 1 to 2, now I'm going from 1 to 1.5, now I'm going from 1 to 1.1. So what I'm doing is, and I don't know if you can visualize this, but I'm moving that secant line closer to a tangent line, just like I did in the demonstration when we talked about that. I'm moving those 2 points, so here's my curve. Wow. Let's try that again. Here's my curve. I'm taking these 2 points. I calculated the slope of that, and now I'm taking this point and moving it closer and closer to that point, which will eventually approach that tangent line.
Along the curve, though, right?
Along, it's got to stay along the curve, correct? It's got to be part of that position function. Okay. So let's skip this one. Let's do this calculation. We know that 1 is at 84. Somebody help me out there with 1.1, please. No, not 82.5. Why do I smell fried chicken?
Yes.
I mean, Cheetos. I mean, not Cheetos, Cheerios. Oh, maybe that's it, yeah.
Cheerios don't smell like fried chicken.
Cheerios,
That's
fried
right.
chicken.
Does anybody else smell fried chicken?
No.
No.
Does anybody else smell Cheerios?
It could be the chemistry. I know I'm getting that funky smell too. Maybe you're having a stroke. Alright.
Wow, thanks, Sam. Well, I am getting pretty old, so you never know. That'd be a good story to tell.
Shoulder pains?
Remember the time in calculus when my teacher had a stroke in front of the class and started smelling fried chicken? Yeah, that was weird. Yeah, I do. I hate when that happens too. Yeah. I think that's an indication. If you go to WebMD and you look up stroke, I think that's like number 2 on the list. Headache is number 1. Smelling fried chicken is number 2. That's how we used to antagonize my grandfather. We'd always make fried chicken without telling him, so he'd always think he was having a stroke. Sure you don't want to write me in your will, Grandpa?
Just keep punching him in the
What
shoulder.
fried
while he's
chicken?
asleep. Just be like, oh god, my shoulder's killing me.
80.64.
Thank you. (84 minus 80.64 divided by divided by 1 minus 1.1. 3.36 divided by -0.1 would be -33.6. Feet per second running out of board. (48 feet per second falling from 1 to 2. Now as we get closer in that shorter time span, it's going to have a smaller average velocity, which makes sense. I mean, you think about when you drop something, it does accelerate as it gets closer to the ground. Okay, so this is it has less time to accelerate, so its average velocity is going to be smaller than after it's fallen for 2 seconds. Okay, does that make sense? It's all based on that position function. And so what we're going to do now is get rid of this and move on to, oh, here, hey, here are all the solutions. Probably should have remembered that. Yeah, slope of secant line, we did that already. Thanks for the help. Yeah, okay. Hope we get, oh, good, same answers. FPS, feet per second, right? Yeah, good. Did you ever use FPS, or was it always FT/SEC?
Never used FPS.
Never used FPS, okay. Well, now you do.
It's a swear word to Mr. Grassi.
Oh, is it?
Yeah, he doesn't really like FPS. He likes feet over seconds.
I'm putting FPS on the next quiz all over it. Every problem is going to be FPS. Calculate the FPS just to antagonize it. All right, so from a calculus standpoint now, we start looking at the instantaneous velocity. So I want to know how fast is that ball traveling at exactly 1 second or exactly 2 seconds. To do that, from a calculus standpoint, we throw the limit in front of it. So now we're finding the slope of the tangent line. That's our second definition of derivatives. The first one, you'll remember we said, is the slope of the tangent line to the curve at the point. The second one is the instantaneous velocity. And it's important that you remember the distinction between instantaneous velocity and average velocity. The derivative is the instantaneous velocity. We talked about the velocity being negative, positive, or zero. Negative going down, positive going up, zero if it's not moving. But this is also important, which I'm sure you learned in physics, is that the difference between velocity and speed. Yes?
Yes.
Somebody other than Cam. Yes or no?
The only one that remembers speed.
Yes.
Go over it again.
Velocity has direction. Speed has no direction. So in other words, if I drop a ball out the window and we do the calculation and it's traveling with a velocity of negative 48 feet per second, that's its velocity. Its speed would just be 48 feet per second. Easiest way to remember that,
Displace.
speed is equal to the absolute value of velocity. Just lose the minus sign. Okay? Don't switch it though.
Do not.
Right. Because that, I mean, some people have done that in the past where they thought speed was the opposite sign, which makes no sense. But you go the other direction, and we don't want to go the other direction. So now I'll have a guy jump off a diving board. I'm sure in physics you derived all these things where well, I'm not sure. Did you?
Yes.
So you figured out where each of these numbers come from. In calculus, we don't care. Most of the time, you're just going to be given, I should say given. You'll either be given the position function, or later on, I'll show you some ways to find the position function using math, not necessarily physics. But here we're given a position function. And we want to know when the diver hits the water. So we'll do part A first. When does the diver hit the water? So what is true about the diver hitting the water?
H equals 0.
Shh, Cam, stop talking. Sam. What happens when the diver hits the water? Is it a he diver? It is. Or it's a woman with no shirt on. Let's go with a he diver.
What do you mean?
When he hits the water, what's true?
Velocity 0.
I'm not going to answer. I'll tell you you're wrong. But think about what that would look like. So you dive off a diving board, and when you hit the water, your velocity is 0.
You just left.
Right? Now, that might be true if you go up on the roof and dive onto the sidewalk. Because really, that's what kills you. It's not the falling, it's the stopping.
Okay.
But into water, your velocity would not be 0.
It's okay.
Okay? What else we got?
I don't know.
Anybody else? Sydney?
But you said it equals 0.
What's it?
The position of the diver,
Why?
because if the diver is 32 feet above the water.
I didn't hear the last
It's
part.
32 feet above the water. So then like something like
she right?
She's not wrong.
She's not wrong, right? I just don't want to volunteer information. I'm 99% sure that you know what you're talking about, but I'm afraid if I open my mouth, I will either give you the answer or scare you away. By the way, your answer is correct. We're going to set that equal to 0, but why? I'm sorry, I used this pronoun also. We're going to set the position function equal to 0. Why?
Because the position of the diver is 0 feet.
Perfect. Good. When he hits the water, his position is 0 feet above the height of the water. Okay. And when we do that, we're going to solve for t, and that'll tell us the time that happens. Okay. Hence the reason it says, when does the diver hit the water? So do that, please. Set that equal to 0 and solve for t. How many answers will you get?
2.
Why?
Because it's a parabola.
Better. Prospect play. Yeah. Just kind of hit. Put in the old college try for one day and take a day off. Is it safe to assume that at this point in time you all have a quadratic formula on your calculator?
No.
What travesty is this? Who does not? Oh, the pain it causes. Really?
I used to when my calculator died.
Yeah, same.
I know.
Mine dies all the time though, so I always have to get it again.
Yeah, try for a new calculator. Or steal someone else's. When Elle's not looking, just reach over.
No, my calculator died last year, and then it broke, so now I have
What's t? Give me both. 2 and -1. Okay, let's talk about each of the, which one, by the way, which one are we interested in? 2. Where'd the -1 come from? How would that happen?
If you went back in time,
Yeah, so Marty McFly is diving off a diving board.
dives back down, and then jumps back up, and then goes down in 2 seconds.
I don't know how you dive off the board.
I don't either. It doesn't make any sense, obviously, because it's negative time, but from a mathematical standpoint, that would happen if you extend the parabola back down to the ground, if he jumped up from the ground to the diving board. No, that doesn't even adequately, never mind. This makes no sense, it's out of there. Okay, so we're gonna go with 2. Seconds. Right, so it takes him 2 seconds to hit the ground. We can do this calculation for just about anything. As we do enough of these, you'll start to recognize the pattern here and start to do all kinds of different calculations. Okay. Later on, we'll be able to generate a formula to figure out, oh, I don't know, if we throw Cam out the window of this room, how long it'll take him to hit the ground. We can calculate, if we know how long it takes Cam to hit the ground, how high off the ground the window is. We can do all those calculations later. They're beautiful. All right. So Sam, let's go back to you. Notice the second question I asked. What's the velocity? And we know it's not going to be 0, so how do we find that velocity? Am I asking for an average velocity, or am I asking for an instantaneous velocity?
Instantaneous.
Beautiful. Okay, so that's the first challenge, is recognizing we want an instantaneous velocity versus an average, which means we're not going to calculate a slope, we're going to use calculus. Right? Any ideas how?
Plug in 2.
Into
Into the equation. That's easier.
do that. Your answer is wrong, but I want you to do that so you see why your answer is wrong. Because what are you going to calculate? What happens at t equals 2? See what you're doing? You're going back and you're being circular about it. So we use set it equal to 0, solve for 2. When you put it back in, you're going to get 2. So your answer is plug in 2, but the question is, where do we plug in 2? If it's not the position function, what are we looking for? And how do we find the velocity? average velocity, we want instantaneous. Alex, how do I find the instantaneous velocity? It's calculus. Sam?
The derivative that you plug into.
Yeah, take the derivative. So we'll take the derivative of s of t, which will give us v of t. Okay, v of t, the velocity with respect to time. And now we get a little practice on what we did yesterday. Abby, what's the derivative of negative 16t squared plus 16t plus 32?
Negative 32t plus 16.
Well done. Then you plug in your 2. 64, negative 48? Negative 48 FPS. Grassies.
Grassies.
I'll fix it. Pregunta?
So what do you do with the equation that you gave us before, the limit t approaching 0 as t?
Great question. Let me get rid of this and go back. This is the fancy schmancy calculus definition. Okay, so let's go back to the beginning of the chapter. We defined this business as the formal definition of derivatives. My whole point yesterday is I don't want to do this over and over again because it's a pain in my butt. So we started creating all these shortcuts. So I could have gone back to this problem and said, okay, let's put an s plus delta s in for t and an s plus delta s in for t, and then do the whole minus thing and then calculate all that out and then take a limit as delta x approaches 0 after everything cancels and we do a bunch of algebra. But Abby was kind enough to tell me that there is a shortcut. There is a shortcut. Somewhere there's a shortcut. There it is. That I can get right to that using the power rule, the constant rule, and all the things we talked about yesterday. Make sense?
Yeah.
Okay. We're never going to plug into that equation. But that's the, again, the fancy schmancy, that's what all the calc guys want you to use. But this is much more practical. Let's see how we did. Yep, yep, good, yep. Okay, good, yep, yep. We talked about this already, right? Why is it negative?
Because it's down.
Going down. Okay, we're all done. Two things left to do today. Number one, I want to talk about some of the problems from yesterday's homework. In particular, I think it's 66 I'd like to look at. And then I have your test to give back today too. Can somebody help me with, what was 66? K minus.
X squared. And then the other one is y equals negative 6x plus 1.
Okay, so one of the examples I did yesterday in class was, or one of the other homework problems I did is I had a parabola and a line next to it, and we shifted the line until it came over and met the parabola. This is different. We're moving the parabola now to meet the line. So I want this line to be tangent to that curve. And the reason I want to look at this is because we now introduce another variable. When I was talking about notation, one of the forms we did was this dy over dx. And as I said, that means the derivative of y with respect to x. So if you have an equation or a function that has other variables in it, let's suppose y is x squared plus cx minus z squared. This notation means take the derivative with x as the variable. Any other non-numerical values, in other words, any other letters, are not variables. Okay. So in other words, if y is equal to c squared and I want to find y prime, what would y prime be?
Just two.
It's a good thing we're going over that. It's not 2c. It would be 0. Okay? And this is why I wanted to look at this problem. Why is it 0? Because that becomes a constant. This notation means that x is my variable and only my variable. However, if I come back here, get rid of this, clear this mess out of here. This is kind of a weird point that I wanted to go over because it pops up a lot. If that's y, then what's dy dc? Now it's 2c. Why? In the first instance, when we took y prime, it's implied that that's a dy over dx, where x is the variable. Since this is a c, it's not a variable, it's a constant. Just like yesterday when we looked at pi. Okay, that's a constant. Now this is saying, I want to take the derivative with respect to, of y with respect to c being my variable. Now it becomes a 2c thing. Is that a little weird? Most of the time we're going to look at an equation like this and we're just going to say, okay, take the derivative with respect to x and we're good to go. It does come up in this problem and you'll see why in a second. Slope of this line is -6. I assume you're all with me on that, yes? I want to move this puppy over to meet this. And I'm going to do that by changing the value of k. I know what the slope of that line is, and so I can express the slope two different ways, from the line or from the derivative. Is this called y in the problem?
F of x.
F of x, okay. In other words, I'm going to find f prime of x. And this is why I talked about this, because now I have to take the derivative of k minus x squared with respect to x. So therefore, what's the derivative of k? 0. Good. So this derivative would be -2x. One way to represent the slope is -2x. The other way to represent the slope is -6. If we set those two things equal, we find that x is equal to 3. Now what does that mean? That means at the point x equals 3, that parabola is going to slide over and meet the line. Okay, are we good? Which means we can find that point on the line. That'll give me the x and y values, so therefore I can find k using that information. Question?
So why you say equal 6? How do you say equal to -6?
What happened to your voice?
No,
You just,
I guess so.
you like just woke up this morning and your voice was gone? You weren't screaming or anything or hollering? Okay. Do you have a nightmare? Sometimes you scream in your sleep and you know, lose your voice that way. That don't happen to everybody? That was common. What was your question? Why did I set them equal? Okay. This is what we want is we want a parabola to come over and meet the line. So I want the slope of that line to match the derivative because the derivative is the slope of the tangent line. Took the derivative, that's one way to express the slope. Got the slope off the line, set the two equal. Okay? Other questions from the homework yesterday? Kevin. Go ahead. Say again, I'm sorry. Four? Tiny 4?
I don't know how to say it.
Fourth root.
Oh, this guy.
Yeah.
Okay, gotcha. That's it? And what do I have to do with that?
Find the
Find g prime of x. I'm going to start by rewriting that. Can you express that as x to some exponent? What exponent is it? Good. Now apply the power rule. Take the derivative. So what's power rule say? 1/4 of x raised to the and I don't know what I had on my answer key. Did I have that, or did I get all fancy schmancy and write it in the bottom and do all of it? I got fancy? I'm sorry. I might have done that on a couple of my answers. Senor?
For like an AP test, show your work, would they accept the power rule, or would they want you to actually, like,
Do the limit process?
yeah,
Oh, no. No, it's all power rule.
okay.
Yeah,
Limit process
the
is
only time a limit process will come up is they'll ask you questions that test your knowledge and understanding of the limit process, not necessarily the application. For the most part, they're assuming that you can do that process, but they'll ask you like how it relates to calculus and tangents of slopes of tangent lines and that kind of thing. That's not to say that I won't ask you on the next test or quiz with a lot of FCSs after it. Anything else? How did the derivative things go? Are you okay with the whole power rule thing? Is it starting to come together? Because what's going to happen is this ramps up pretty quick. We're going to start to run into problems where we're going to want to take the derivative of functions that have multiplication in them, which means we're going to need a new rule. Or we're going to want to take the derivative of something that has a quotient, we need a new rule. So we get into some weirdness, so I want to make sure that you have a solid foundation on basic power rule and constant rule functions or problems before we proceed to the uglier stuff later on. Okay?
Can we get 56?
If you tell me what 56 is, yes.
Is function y equals x to the third plus x with a point at -1, -2. And then you have to, part A, to find an equation of the tangent line to the graph of the f at the given point.
Let's just do that first. Equation of tangent line, I need two things. I need a slope, I need a point, I got a point, need a slope. Right? How do I find the slope?
You just take the derivative,
Beautiful. What's the derivative of that function?
3x squared plus 1.
That's a general equation of the slope. I want a specific value because you can't plug that into a tangent line equation. I need an actual numerical slope. How do I find a numerical slope?
You just plug in -1.
Perfect. This works for anywhere on the curve, but I don't care about anywhere. I care about this one particular point. So plug -1 in here. I get y prime of 1 is equal to 4. Okay. Got a point, got a slope. Y plus 2 is equal to 4 times the quantity x plus 1. Done. What was part B?
Use a graphing utility to graph the function and its tangent line at the point. So
I guess they just wanted you to get a pretty picture of what that looks like. So put x cubed plus x into y1, put y plus, or you'd have to move the 2 to the other side, but do y equals 4 times quantity x into y2 and graph it so you can see a pretty picture. See,
Why did you plug in 1?
I didn't, no, that's wrong. I did this, thank you. Good catch. That's a -1. My bad. Good. So we're also going to progress, that's okay, I'll get to you in a second. We're also going to progress with less theory and more application. Okay, so the first section was pretty bogged down in conceptual stuff. Here we're going to get into more mechanical stuff. What do you got?
60. It's the same equation.
That we just did?
Wait, yeah, we might have been points where the graph has a hole in
Oh.
y equals x.
Oh, yeah. What's my equation? X cubed plus x?
Yeah.
Okay. Oh, this is another good one. Why do we care about graphs having horizontal tangents? Well, first of all, what's the slope of a horizontal tangent? 0, right. So this is a cubic. So let's suppose it looks something like this. This becomes a big thing for us in the future. We want to find points where the tangent line is horizontal. So we have one here, Gesundheit, and one down here. And the reason we care so much about those is because this is what's called a max and that's what's called a min. We'll be calculating those a lot. Now, the big question is, how do we do that? How do I find those 2 points on the curve where the horizontal, where the tangent is horizontal? I'm not giving you this one. John?
Do you want to take the derivative?
Okay, we could do that. We did that already from the last one. Okay, so y prime is equal to 3x squared plus 1. That's the slope of the tangent line anywhere on the graph.
And then plug it for 0
Plug in 0
for x,
for x.
and then you get 1.
And if you plug 0 in for x, that'll tell me the slope of the tangent line at the point x equals 0.
Okay.
It's a good start, though. I appreciate the attempt. What's true about these 2 red lines? Say again? Or don't. Okay. Sam?
Well, it doesn't not exist because the slope will always be, or will never be 0.
But the slope is 0.
Yeah, but
Because they're
aren't
horizontal.
there none then? That's what the answer key says. I'm just saying, but isn't that why? Because
You're putting the cart before the horse.
doesn't there have to be no places where the slope is 0
Because you know what the answer is already.
no, but in because it's squared, so it can't be -1.
I don't know what, I think you're almost there, but you need to be more specific because we're very confused.
So the x is squared, so you can never
No,
have
go back. Okay, go ahead. So the x is squared.
So you can never have a value for x where it's -1, making the slope 0.
Ah. The slope equals 0.
Yeah. At those points, the slope does. And you're solving for the slope, so.
Ah. I did solve for the slope.
Yeah, but to actually find the slope at those points, you can never have a point where the slope is 0.
Yes. Does that understand what he's saying?
No.
He's right there. He's just not actually saying it. Casey.
So the derivative of that.
Shh. Is your name Casey?
Is there is there
Noah. Noah's
point
not
where
here.
the slope is 0?
He's in 6th period.
No house.
Go ahead. I'm sorry.
Is there no point where the slope is 0 because
Wait. Oh, stop. Hold on. In this particular problem, we'll get to there in a second. We still haven't addressed the major issue there. How do I find these 2 lines? What's true about these 2 lines?
Don't you just set it equal to 0?
There we go. Set what equal to 0?
Y prime.
Bingo. That's what I needed. Was everybody there and I was just missing it?
No.
No. Okay. This is one particular instance. I can change this problem to be a lot of different things. I could ask, where is the tangent line have a slope of 1/2? Where does it have a slope of -2? However, these pop up a lot. I want to know where they're horizontal because that's going to give me these things called maxes and mins. Okay, now that we've addressed that, let's go back to what you were talking about, Sam.
Since it's
Why is this that?
Because it can't be negative.
Move the 1 to the other side, divide by 3, I get x squared is equal to -1/3, which means that you can't take the square root, so there's no. So my drawing is wrong. It would actually look something like this. It doesn't happen. Okay, good. I knew we'd get there eventually. We just had to deal with the general concept versus the particular concept. And again, it comes down to the idea of having two different ways to represent a slope. One way is the derivative, and one way is either from a line or given information or something other than the derivative that you set it equal to. Kev?
I just had another question.
Sure.
32.
Yeah?
I don't know the problem now.
Somebody might be able to help.
The function is ft is equal to 3 minus 3 over 5t. And then the point is 3 over 5 and 2. And it says find the slope at the point.
Okay. So to find the slope, we're going to take the derivative, plug that in. I would start by rewriting this that way. Then take the derivative. Once you get that derivative, plug in 3/5, and you get the slope.
That's it.
Yeah. We can do this in 7 minutes, I think. Yes?
I know, I got lucky, because like the doctor was